proportional relationships. Okay. So proportional relationships has to do with proportions. That is an equation in which both sides are equal to one another. This is how you know all of algebra to be, right? 2x equals 4. We know x equals 2 because it's the only thing you can multiply 2 by in order to equal 4. Both sides must be equal to 4. It's a proportional relationship. We have two types of proportional relationships. We have directly and inversely. If you're in Algebra 2, I think you're learning this in class now. If you're not, don't worry. This isn't difficult. So directly proportional, as one variable increases, the other also increases. Directly. As one increases, the other also increases. So directly proportional, as one increases, the other one increases. So as V goes up, T does what? Goes up. As V goes down, T also goes down, right? All variables, okay, variables change in the same direction, right? Directly proportional. They change in the same direction. If one goes up, the other goes up. If one goes down, the other goes down. For inversely proportional, as one increases, the other must decrease, right? Because we're trying to keep both sides equal. So P1 V1 equals P2 V2. This is one of the equations we'll be using that is inversely proportional. Notice how the two different variables are being multiplied by one another. That's how we know it's inverse. So as P goes up, V goes down, right? They're inversely proportional. Okay? So variables change in reverse. If you know what the word inverse means, then that should make sense to you, but if you don't, or if it's not a common word to you, reverse makes sense to you. You put your car in reverse, right? So they change in reverse. And remember, these are proportional. So if P goes way up, V goes way down. If P just goes a little tiny bit up, then V just goes a little tiny bit down, right? It's proportional relationships. Okay. Now, make sure you understand inversely and directly proportional. I promise you one of your tests, one of the questions on the test will be, okay, look at this formula. Is this inversely or directly proportional? Now, this is not something that you should have to memorize, okay? Because you should be able to logically think these through. Either you memorize the relationships, okay, if the variables are being multiplied, then that's how it works. Or you can just think about it in terms of the math. So if I try and make, let's see, do this. Okay. So if I say that V1 and T1 equals V2, T2, let's say that this is equal to 20. Okay. So if I started out with 40 over 2, that equals 20, right? And if I change 40 to 80, what happens to my T? What is, to 4. So as my volume went up, what happened to my temperature? It also went up, right? These are just made up numbers. If you ever need to analyze an equation, see if it's inverse or direct, make up some numbers. See what happens. Okay, same thing here. If I say this is equal to 20, and I start out with a pressure of 4 and a volume of 5, that equals 20, right? Now, what if I change my pressure to equal 5? What happens to my volume?
4.
It goes down. It becomes 4. All right? As my pressure went up, my volume went down. Pretty simple. So So the variables we're going to be using throughout this entire unit are the following. We have temperature. Ooh. Temperature is T. Pressure, P. Standard temperature and pressure. Well, standard is S. Temperature is T. P is pressure. So STP. Volume V. And moles of gas is N. That's the only thing that might seem strange to you. It's because we ran out of M's. The way to learn that one is, okay, N equals the number moles gas. Okay. So Boyle's law, this is going to be our first gas law that we're going to be talking about. So Boyle's law describes the relationship between pressure and volume if you keep a constant temperature. Now remember that a law, it's not an explanation. A law is a fact. The law of gravity, if I drop something, it falls, right? If I let go, it falls. It is just a fact. It's not actually an explanation. Boyle's law is just a fact. Pressure is inversely proportional to volume. That's just a fact. It's something that he showed over and over and over again in a lab and goes, voila, now I have my own law. I'm Boyle. This is Boyle's law. Okay? His equation is P1V1 equals P2V2. Okay? Now, when you think Boyle's law, I want you to think of the balloon. I'm going to draw it out on the side, but I'm sure you can find a spot for it. Okay, think of that balloon from yesterday. It doesn't have to be this big. Just draw it small. What happened as I decreased the pressure around the balloon?
It expanded.
It expanded. My volume went up, right? What would happen if I increase the pressure?
The volume would go down.
Right? Volume would go down. So anytime you think Boyle's law, I want you to think balloon. Boyle's law, think balloon. So what do these subscripts mean? Okay. So if I have the subscripts, P1, right, V1, P2, V2, what this means, it's my pressure and volume before and after a change. So P1, V1, this is what I start with. P2, V2, this is what I end with. That's too light, isn't it? Okay. If I have 5.6 liters of gas in a piston at a pressure of 1.5 atm, and I compress the gas until its volume is 4.8 liters, what will the new pressure inside the piston be? Notice these will all be word problems. The only thing you really have to do here is be able to identify, was this a starting or an ending pressure or volume? So if I have 5.6 liters, liters is a measurement of volume. This is the volume I started with, therefore that is V1, and I plug that in, V1, 5.6 liters. So next I have 1.5 atm. ATM, that is a measurement of pressure. This is what I had before I compressed it, right, before I changed it. So this is P1, right, and I plug that in. I compress it until the volume, right, is equal to 4.8 liters. Now it even said volume that time. So volume is 4.8 liters, and that was after I compressed it, so that's V2, plug it in. The only thing that's left is P2. Simple algebra. Now, your units must be the same for both volumes and for both pressures. So I have 1.8 atm. Another way to know this is if I was to actually do the math, 1.5 atm times 5.6 liters divided by 4.8 liters. Okay, my units cancel. Right, liters and liters cancels. My only unit left is ATM. Notice if I had liters and milliliters, that wouldn't work. So they must be the same unit. If you're given one that's in liters and one that's in milliliters, you have to convert to find the difference. So what would happen if P is increased, V will decrease. This is inversely proportional. I'm just going to draw an arrow. You can do the same. Number 2. I'll do number 2 with you. If I have 1 liter of gas at standard temperature and pressure, anytime you see standard temperature and pressure, make sure you underline it or something. That should be very important to you. And it is compressed to 473 milliliters. If you struggle with this type of algebra at all, you need to go through and identify all of your variables before you get started. So my possible variables are P1, V1, P2, and V2. Okay. Pressure 1, do I have a pressure 1? I have standard temperature and pressure, which means 0 degrees Celsius and 1 ATM. Therefore, my starting pressure is 1 ATM. My volume 1 liter. Pressure 2, I don't think I have one, so that's probably going to be my variable. And volume 2, I have 473 milliliters. So what's wrong with my variables?
Milliliters and liters.
Liters and milliliters. They won't cancel if they're liters and milliliters. So I need to convert one to the other. I don't care which. They just have to be the same. I don't have as much space by the liter, so I'll switch milliliters to liters. Okay. You either do a T-chart or you know how many times to move the decimal place. 473 milliliters is equal to 0.473 liters. Now all you need to do is plug all these into your equation. Okay. So I have 1 times 1 equals P2 times 0.473. P2 equals, now how many sig figs do I have?
3.
3 here and 3 here, so I need 3 sig figs. All right, 1 times 1 divided by 0.473, and I get 2.11. What's my unit on pressure here? ATM. For your homework, you must have at least this. All right, you at least need to plug in each of the numbers into the equation and solve the answer, have sig figs and units. Okay, you don't have to do this whole identifying variables part. I highly suggest it. If you don't look at this and this makes obvious sense, I highly suggest go through, identify all 4 variables, and then plug them in.